morning, students. How are you? This is Ankit Joshi. I welcome you all on India's largest e-learning platform, BYJU'S Exam Prep. Students, I just request all of you to respond whether am I audible or not. Those who are online, they can show their presence in the comment box. We are waiting for your response. How is your preparation going on? Come on. The students, today we are going to discuss the questions on analog circuits. So as you all know that these exams, BARC, DRDO, ISRO, and these similar subsidiary exams, in these exams, number of questions are 100, but the time allotted is less as compared to the GATE exam. So the level of the question is such that it will not involve much of the calculations, but it will be definitely involving a lot of basic concepts. So students, conceptual questions will be there, questions with bit small calculations will be there that you need to answer. There may be questions which involves lengthy calculation, but that you need to skip because otherwise you will not be able to attend or attempt all the questions or maximum number of questions. Gautam Narayanan, how are you? Welcome to the session. Let's proceed. So students, today's session for BARC 2023 Super 15 for Analog Circuits. This is the brief introduction about me. Students, I have been teaching in this domain since many years and my subjects of interest are engineering math, signals and system and analog circuits. So students, today in this session we are going to discuss questions from analog circuits for BARC 2023. Students, let me announce that on 19th of March 12 p.m. there is a scholarship test and there you will get an opportunity to avail scholarships up to 90%. Don't miss out this opportunity. BYJU'S always works in favor of their students. Needy students will get this scholarship. Just you need to perform in the scholarship test. Note down, block your calendar for 19th of March, 12 p.m. afternoon. So students, no Pinky, this is the session for Analog Electronics for BARC. So on your screen there is a current mirror circuit. Yes, please comment in the comment box which circuit it is. It is a current mirror circuit. So we have got two BJTs connected back to back. So just go through the question. In the adjoining current mirror circuit, if Q1 and Q2 are identical, Q1 and Q2 are identical means they are matched transistors. So base currents are not neglected. Then which of the following is true? So students, just go through it. So students, if this is current I1, I can split this into two parts. This is collector current. Since the collector currents for both the transistors will be same, I'm just marking it as IC instead of IC1 or IC2. This is IB. This current will also be IB. So IB and IB will be ultimately twice IB. So this current will be twice IB. Very good. Ashok, Pinky, very good. 2 times IB will be this current. So if you apply Kirchhoff's current law at this node, you will get I1 will be IC plus 2IB. I1 will be IC plus 2 times IB. Comfortable till this? Now students, IC, we know that collector current IC is beta times IB. So this I1 will be beta IB and again 2 times IB. Yes, Bholenath. Very good. I1 is ultimately beta plus 2 IB. Now students, this IB can be converted to IC. What is IC? IC is yes, IB is IC upon beta. IC upon beta. And as we know that this current I2 is entering into transistor Q2 here, so this is nothing but IC. So IC can be replaced by I2. This is I1. I1 will be beta plus 2 upon beta multiplied by I2. So this is the calculation based. You can directly, this is the standard formula as well. I have derived it for you. I2 is beta upon beta plus 2 I1. Beta upon beta plus 2 I1. This is our option C. Comfortable? Just go through it. So this is the current mirror circuit. Students, you can collect the PDF of today's session from my Telegram group Electronics by Ankit Sir. Let's move to the next question. I'll just hide myself so that you can take the screenshot. Done. Next. Now, the transistor amplifier with 85% of efficiency is likely to. So, students, in the options you can see class A, class B, class AB, and class C. It means these are power amplifiers. So, in case of power amplifier, for class A power amplifier, there are two categories: direct coupled and transformer coupled. So theoretical maximum efficiency of direct coupled class A power amplifier is 25%. Theoretical maximum efficiency of class A transformer coupled is 50%. For class B, you have two configurations: push-pull and complementary symmetry, that is Cauchy configuration. In class B configuration, there are maximum possible efficiency something around 78%. For class AB, efficiency will be lying between 50% to 78%. But for class C, the maximum theoretical efficiency can go beyond 90% also. So 85% efficiency, this figure is possible. This figure is possible only with class C configuration. Okay, this figure is possible only with class C configuration. Comfortable? So for class C configuration, efficiency can be 85% as well. So any confusion, please let me know. Any confusion, please let me know. So done with this, we are moving to the next question. Aji Pinky, 78.5, you can say 78.5, around 78.5 for class B. For class B configuration, there is one more very important point, that maximum efficiency, that is maximum AC power output and maximum distortion, both cannot occur simultaneously. So I am giving you certain one-liners that can be asked directly in your upcoming exam. Again, a question from power amplifier. In a class AB amplifier, the current flows through the active device for. So students, in this particular question, they are asking for the angle of the collector current. So I want to give you the concept behind this. So I will be drawing the DC load line and AC load line. For that, I will be plotting the characteristic so that you will get the complete idea. So all my dear student, this axis is VCE axis. This one is IC axis. Okay, and now I am drawing. So this is our DC load line. Okay, sir. Now I am marking the positions of Q point. If the Q point is located at the center of the active region, this corresponds to class A operation. If the Q point is located at the junction of active region and cutoff region, yes, very good. At the junction of, this is active region and this is cutoff region. If Q point is located here, then this refers to class B. And if Q point is located somewhere between these two positions, then we can say that it is class AB. So this middle position, somewhere between these 2 points, somewhere between class A and class B, it is class AB. And if Q point is located in cutoff region, then it will be class C. Okay, so students, when someone asks you the angle of collector current for these different classes, you can definitely answer in this manner. See, for class A operation, you will get the collector current for complete 360 degree. For class B configuration, angle of collector current is 180 degree. For class AB, angle of collector current will be lying between 180 to 360. It means you will get collector current for more than half cycle but less than complete cycle. Yes. For class C, angle of collector current is less than 180 degree. So this is the logic. So currently they are asking for class AB configuration. What is the angle of the collector current? So more than half but less than full cycle duration. Option C will be the correct one. Can I have your response? Next. Now this is a question. This is a question from feedback amplifiers. Feedback amplifier. So students, a feedback amplifier shown in the figure. Each basic amplifier stage has an open loop gain A equal to 10. The closed loop gain is AF equal to 100. If the gain of each stage is increased by 10%, what is the percent change in the closed loop voltage? So we can target this question in multiple ways. The simplest way I am going to give you, just I will be drawing a closed loop amplifiers diagram. This is open loop gain. Here I am having an adder circuit. Here the input is coming. This input is added out of phase with this signal from feedback factor. This is the output and this is the feedback signal. Yeah. So students, see here in this diagram, 3 open loop amplifiers are connected in cascade, each having a stage gain of 10. So 10 into 10 into 10, the overall gain of these 3 will be 1000. So here open loop gain, say A dash, this is 1000. Okay sir. And feedback gain or gain with feedback, that is AF, it is A upon 1 plus A beta. I am not using the letter A because A is already utilized in the question. Now students, AF is given to us. AF diya hai humko, AF is 100. AF is 100. A dash is 1000, that is open loop gain. This is the net gain of the cascading of 3 open loop stages. 1 plus 1000 beta. So students, you need to work out this, solve this. What you will get? You will get beta. Beta will be, yes, 0 0 0 0 cancelled. So 9 upon 1000. All my dear students, beta is 0.009. Comfortable? So with this value of beta, we are going to proceed. Now see here, what they are saying, if the gain of each stage is increased by 10%. Hello, currently the gain of each stage is 10. If you increase it by 10%, then it will become 11. New gain. So new gain will be 11. So students, new gain with feedback will be A dash new upon 1 plus A dash new into beta. So all my dear students, A dash new will be 11 into 11 into 11, that is 1331. Again 1331 multiplied by beta 0.0. So all my dear students, this will come out as 102.55. So this is the new gain with feedback. Now they are asking what is the increment. What is the increment? So that increment is AF new minus AF, 102.55 minus 100 will be 2.55. So percentage rise, that will be 2.55% increase. So with respect to 100, 2.55 is increased. So they are asking what is the percent change in the closed loop gain. So percentage change in closed loop gain will be 2.55%. So this type of questions we can expect in your upcoming BARC exam. Subsidiary exams requires conceptual questions, but that needs to be solved very quickly. See this. Consider a basic amplifier circuit having input resistance Ri equal to 10 kilo ohms, and output resistance are not equal to 1 kilo. Good morning, Ashok. How are you? Now they are saying that loop gain they are denoting by T. I'll explain what is this loop gain. Loop gain is 1 plus A beta. This is given as 10 raised to 4. Now what are the maximum possible output resistance? Okay, we need maximum value of output resistance. So maximum value will be possible when output resistance is multiplied by 1 plus A beta. Very good. And then we need minimum possible value of input resistance. Input resistance with feedback, this will be minimum when Ri will be divided by 1 plus A beta. And 1 plus A beta is already mentioned in the question. So students, R0 kitna hai? R0 is 1 kilo ohms. 1 plus A beta is 10 raised to 4. 10 raised to 4 into 1k, it means it is 10 raised to 4 kilo ohms. And Ri kitna hai? What is Ri? Ri is 10k divided by 10,000, that is 10 raised to 4, that will be 1 ohms. So first value we are expecting is maximum possible output resistance. Maximum possible output resistance is 10 raised to 4k. Yes sir. And minimum possible input resistance is 1 ohms. So option D is the correct one. So be careful, students, be careful while solving these questions, because when you are solving such questions, you need to be very keen in understanding what is the first answer and what is the second answer. Okay, just by reversing this, swapping these, they have made one more option, option A. By mistake, some of the students may mark option A as well. So be careful in such type of questions. Question paper setters bound to make you mistakes. See, next, which of the following harmonic component has main distortion in total distortion in an amplifier? Students, we know that there are distortions, there are amplitude distortion, there are phase distortion, but when we are talking about the amplitude distortion due to the presence of unwanted frequency components, that is called as harmonic distortion. Amplitude distortion due to the presence of unwanted high frequency components are called as, is referred as harmonic distortion. So harmonic distortion, when you consider harmonic distortion, second harmonic is the most harmful component. Second harmonic is the most harmful component. So I want to give you some more concepts regarding this. Suppose the net current is V0 is the DC component, V1 sin omega t, sin omega naught t. See, this omega naught is the fundamental frequency, and the coefficient of this fundamental frequency component is B1. So this is the fundamental component, this is the DC component. Then we have V2 sin 2 omega naught t. So 2 omega naught t, this is second harmonic. The coefficient of second harmonic is B2. So this is actually the second harmonic. B3 sin 3 omega naught t, and so on. All my dear students, as the frequency increases, we know that omega naught is less than 2 omega naught, is further less than 3 omega naught, which is further less than 4 omega naught, and so on. So for omega naught, what is the coefficient? B1. This is largest. B1 will be greater than B2, will be greater than B3, will be greater than B4, and so on. So we can see here, as the frequency is increasing, amplitude is decreasing. Amplitude of a harmonic is inversely related with the corresponding frequency. Okay, higher the frequency, lesser the amplitude. Now see the formula for distortion. Distortion. The total distortion is D, which is the norm of all the distortions. Distortion actually starts from D2. So D2 square, D3 square, D4 square, and so on. So there may be nth harmonic or infinite number of harmonics. Now what is this D2? So D2 is B2 upon B1. If you are interested in percentage second harmonic distortion, so multiply it by 100. Similarly, what is percentage D3? This will be B3 upon B1. Always in the denominator you will get B1, and B1 is the largest, so we can say that D2 is the largest harmonic distortion as compared to the other ones. Okay, are you following my point? So as far as the harmonic distortion is concerned, D2 is having the largest value. So D2 is intolerable. Okay, you cannot tolerate D2, a harmful component which absorbs most of the input energy. Now, apart from this, if you are talking about the load current, then definitely this B0 is the DC component, but this is generated due to the presence of the harmonics. So already existing DC component is already there in the BJT based amplifier, that is ICQ. So the total DC component in a harmonic contained output will be ICQ plus B0. Remember this, okay? And when you talk about the AC power output of an amplifier with distortion, how you are going to write the expression, that is also important. So AC power output with distortion, it will be 1 by 2. See, you know Im square into RL by 2, that is peak current's peak value square into RL by 2. Yes sir. So that first component, fundamental component, will be B1 square into RL by 2. Then second one will be power contained in the second component will be B2 square into RL by 2. In the third component it will be B3 square into RL by 2, and this will go up to infinite. So if you take 1 by 2 B1 square into RL common, then you will be getting 1 plus B2 square by B1 square, then B3 square by what? B1 square, and so on. So students, this one is nothing but the AC power output without any distortion, and this is 1 plus B2 square, B3 square, B4 square, and so on. Are you following? So AC power output with distortion, AC power output with distortion is AC power output without distortion multiplied by 1 plus. Now what is this? The sum of all these components will be distortion square. The net distortion is D. So if you square it, this square root sign will be removed, so you will get this one. It means a lot of power will be consumed by the harmonic components, and that will be also available at the output, creating unnecessary heat at the output component. So this may lead to damage of your device. Okay, so with this explanation you would be able to answer so many questions related with the harmonic distortion. So have you all followed what I explained? And have your response fast. Now see this. Use of morning Bablu Saha, how are you? Use of a series shunt negative feedback in an amplifier will. What is the impact of series shunt feedback? So students, do you want to know the concept behind this? I will be just summarizing the concept of feedback with the topologies. Please try to understand. See here. This is my open loop amplifier A. Okay, and this is my feedback factor beta. See here, this is open loop amplifier. Yes, and this is feedback factor. Now at the output side you are connecting the load resistance. and at the input side you are connecting the source. Okay, so students, at the input you can have two types of sources, voltage or current. So if there is a voltage source, now see, listen carefully. When they are saying that it is series shunt type of feedback, कौन से प्रकार का feedback है? Series shunt feedback. Series shunt feedback. It means series type of connection required at the input side and shunt type of connection required at the output side. Remember this. So series type of connection required here, यहाँ पर, here we require series type of connection. And shunt type of connection required at the output side. Now you tell me, have you all got this? So this is series connection. And these are shunt type of connection. Now listen carefully. Connection between this connection is connecting the output of the feedback to the input. It means the output of the feedback network is mixed with the input signal. So this is actually the mixer circuit. ये क्या है? This is the mixer circuit. Mixer. If the mixer is series mixer, then it represents voltage mixing or series mixing. This implies that the input signal must be a voltage source. So this mixer is a voltage or series mixer. Now coming on to the output side. At the output side, if you can see shunt type of connection. Okay, so this shunt type of connection represents shunt sampling. What type of sampling is it? What is this? At the output, we are sampling the output. At the output side, we are sampling the output and providing it to the feedback circuit. So this is the sampler circuit. Sampler. So sampler, if it is node connection, then it is voltage sampler. Okay, node connection means shunt sampler or node sampler. So students, if mixing is series mixing, it corresponds that input is voltage. If sampling is shunt sampling, then it corresponds that output is also voltage. So the amplifier circuit in which input is voltage, output is voltage. So this is a voltage amplifier. And if you are having a voltage amplifier, then it always requires a voltage series feedback. So voltage amplifier is involving voltage series feedback. Voltage series feedback is also known by the name series shunt feedback. Now this series word is copied here and this shunt is copied here. So shunt feedback means this shunt corresponds to which signal is sampled. So this is the sampling signal. So sampling signal is voltage. It means shunt type of connection. So voltage series feedback is also known as series shunt feedback. So students having slight basics, they can easily understand what is happening here. Now student, if it is a voltage amplifier, then with the introduction of feedback, input impedance will be improved and input impedance will be multiplied by 1 plus A beta, and output impedance will also improve and it will be divided by the factor 1 plus A beta. So with the help of this feedback, what is happening? Input impedance is increased and output impedance is decreased. So just you need to remember that if it is a voltage amplifier, then ideal input impedance is infinite and ideal output impedance is zero. Actually, practical input impedance is Ri, which is improved with the help of this feedback, and actual output impedance is Ro, which is further reduced with the help of this feedback. So actually, this feedback is providing an improvement over the circuit. So increase input impedance and decrease output impedance. Option A is the correct one. Option A will be the correct one. Option A will be the correct one. So I can give you some more mappings if you want to, if you are ready to listen this. See, types of open loop amplifier. There are 4 open loop amplifiers. क्या नाम है उनके? Voltage amplifier, current amplifier. This X stands for transconductance amplifier. And fourth one is trans resistance amplifier. So there are 4 amplifiers. These are open loop amplifiers: voltage amplifier, current amplifier, transconductance and trans resistance amplifier. Now, by providing feedback to these open amplifiers, by providing negative feedback to these open loop amplifiers can be converted to feedback amplifier. Are you getting my point? So, in voltage amplifier, what is output signal and what is input signal and what is output signal? In voltage amplifier, input and output both are voltage. In current amplifier, input and output both are current. In transconductance amplifier, input is voltage, output is current. In trans resistance amplifier, input is current and output is voltage. So what is open loop gain? Open loop gain will be unitless. Arey bhai, when you are dividing output voltage upon input voltage, you will get unitless value. What is open loop gain in case of current amplifier? It is again unitless. When you are dividing current by voltage, you will get conductance. So unit of conductance is ohm inverse O. And when you divide voltage upon current, that is output upon input, voltage upon current, you will get resistance. Unit of resistance will be ohms. So students, these are the open loop gains. In notation format, you can write them as AV, AI, GM and RM. So this is the scenario with open loop gain. What are their ideal input and output impedance? What are their ideal input and output impedances? That is also an important map. So students, for voltage amplifier, input impedance ideal value is infinite, output impedance ideal value is 0. For current amplifier, just swap these values. Ri is 0 and R0 is infinite. For transconductance, Ri, yes, infinite. R0, infinite. Transconductance input is voltage, so infinite, and output is, so both are infinite. For trans resistance, Ri is 0 and R naught is 0. So these are the mappings for input and output impedance. And when you provide feedback, you are actually approaching towards this ideal characteristic. Okay. If the emitter bypass capacitor in a common emitter amplifier is removed, then what happens? Very simple. See here. I am just drawing the output circuit of an emitter amplifier. Here we have a capacitor. This is case 1. In case 2, we have removed this capacitor. Now see, this is resistance Re. This is emitter bypass capacitor. Now, what is the role of this Re? When this Re is connected, it provides negative feedback. So, due to the presence of this capacitor, during AC operation, Re is bypassed by this capacitor. So, negative feedback is removed. No negative feedback in this circuit. No negative feedback means gain is large. And when capacitor is removed, negative feedback is introduced. Due to negative feedback, gain is decreased. So what happens when you remove a capacitor, emitter bypass capacitor? Once the gain was large, now the gain is decreased. So gain reduces. Voltage gain will decrease. Option C is the correct answer. Voltage gain will decrease. Voltage gain will decrease. Comfortable with this? The role of this emitter resistance is to provide negative feedback. But that negative feedback will be acting only when this Re is present in the circuit during AC operation. So during AC operation, in the first circuit, capacitor will be shorted and it will bypass this Re resistance. Due to this, negative feedback will be eliminated, gain will be large. In the second case, when you remove the capacitor, Re is actively present in the circuit during AC operation also, and due to this, negative feedback will be present in the circuit and consequently gain will be lowered. So gain or voltage gain will be reduced when emitter bypass capacitor is removed. Students, can I have your response? Now see, this is a simple circuit. If you observe this represents the feedback part, RF. And this one is the Ri. So gain of okay. So non-inverting terminal is grounded. So this is an inverting amplifier. For an inverting amplifier, voltage gain is minus Rf by R1. And if you are asking only for the magnitude, then only Rf by R1. So in the first case, when the switch S is closed, okay, in the first case what happens? Switch S is open. When switch S is open, the gain of this circuit is X. What will be X? Rf upon R1. So R plus R, 2R upon R, this will be 2. When we talk about when switch S is closed, when this switch S is closed, what happens? This R will be bypassed by this short circuit and only resistance R will be actively present in the feedback path. So X new will be R upon R, this will be 1. So X new is X upon 2. Can we say like this? So when the switch S is closed, the magnitude of the gain becomes X by 2. Yes, the new gain becomes X by 2. Option A is the correct answer. Comfortable? I have just not considered the sign because they are talking only about the magnitude. That is it. new gain is half of the previous gain. New gain is half of the previous gain. It means x new will be x by 2. Comfortable everyone? Ashok Chaudhary. Let's move to the next. Ripple factor of a half wave rectifier. This is a value based question. I have seen this question in GATE exam as well. I have seen this question in many subsidiary exams as well. So ripple factor of a half wave rectifier is 1.21. They are not asking you to derive anything. What is the ripple factor of a full wave rectifier? Full wave rectifier का ripple factor क्या होता है? .48. That's great. Very good. For full wave rectifier, ripple factor is 0.48. Yes, Ravi, कैसे है बेटा? And for a half wave rectifier, it is 1.21. Next, see this question. For the circuit shown below, the value of the voltage gain AV V0 upon Vi. Now see here. According to the concept of virtual ground, this is 0. This potential will be 0. If this is 0, this is also 0. So 0 means ground. This is also ground. So this 60 kilo ohms is virtually disconnected from the circuit. I am also fine, Ravi. So this will be virtually disconnected. So the equivalent circuit will have this as RF, this is R1. So this is an inverting amplifier. So its gain will be minus RF by R1. You can derive also. No need to derive here. Minus 400 kilo ohms upon 40 kilo. That will be minus 10. So minus 10 is the answer. Minus 10 will be the answer. Comfortable? Comfortable everyone? Very simple. Any doubts? Please raise it now. Let's move to the next. Okay. So this is a calculation based question. I just framed this question to force you to remember some formula as well. So determine the ripple factor of an L-type choke input filter comprising a 10 Henry choke. 10 Henry choke, 10 Henry is the value of inductance, and 8 microfarad capacitor. Used with a full wave rectifier where frequency is 50 Hz. Now students, just a moment, Pratap, I will get back to you. Now concentrate here. Students, L-type filter. See here. This is a full wave rectifier. The output of this full wave rectifier is directly connected to the load. So this output present at the load will be having a lot of ripples. To reduce those ripples, we have to connect a filter section here. This filter can be capacitor input filter, inductor input filter, L section filter, that is choke input filter, what we say L type filter, or it can be a CLC filter, that is pi filter. So I'm just drawing its diagram. This is full wave rectifier. So this is how L and C components are connected, and this is your RL. Now students, for this circuit, that is rectifier along with L section filter, ripple factor formula is modified as 1 upon 6 root 2 omega square LC. Omega is nothing but 2 pi f. So here each and every value is in front of you. So this is the formula for ripple factor for L section filter, that is L type filter. Remember this, or choke input filter. 1 upon 6 root 2 omega square. Omega square is 2 pi f. F is 50. LC. L कितना है? 10 Henry and 8 micro. Just work out this and let me know the value of ripple factor. You want me to calculate? $50 है भाई, है ना? 50 hertz, not 500. So 100 pi square into 8. My answer is 0.014926. Yes, Ashok. See, for a full wave rectifier, ripple was 0.48. So 0.48 is now reduced to 0.0149. Okay, 0.48 divided by 2.0. So this is reduced 32 times. So ripple is reduced 32 times. Understood? So this is the advantage of having filter in the rectifier section. Done? So this is the formula for L type filter, and I request all of you to remember this formula, as this can be directly used. This can be directly used in the questions coming in upcoming BARC exam. Remember this. This is for L section filter. Okay? Yes, sir. Sir, why this is called as choke input filter? Very simple logic. You need to observe load from rectifier side. So when you are observing load from the rectifier side, what is the first component? जब आप रेक्टिफायर सेक्शन की तरफ से लोड को देखते हैं तो फिल्टर सेक्शन में पहला कंपोनेंट कौन सा दिखाई दे रहा है? The first component you can observe is inductor. Therefore, this is called as, this is the type of inductor input filter. So L section filter, L section filter, I'm not getting Sandeep what you are trying to say. L section filter is an inductor input filter or choke input filter. Okay, remember this. Now Pratap has raised one doubt in the previous question. Pratap is asking how this 60 kilo ohm is removed from the circuit. Very simple. By the concept of virtual ground, Pratap, are you there? This non-inverting terminal is grounded. So by the concept of virtual ground, this inverting terminal is also grounded. So this is at zero potential, this is also zero potential. So this is zero potential, means this is also zero potential. So 60 kilo ohm resistance has zero potential at both its ends. Arey bhai, for a resistance, the potential difference is zero. So will the current flow through that resistance? No. So this particular resistance is isolated, electrically isolated from the circuit. Okay? Can I have your response? Students, are you enjoying? I request all of you to hit the like button if you have not done so. Yeah. संदीप सोनू, LCL नहीं होता बेटा, CLC होता है. LCL does not exist. You will be having CLC filter. Students, I request all of you to hit the like button if you have not done so. If you are really enjoying this session, I request you to comment in the comment box. चलिए next. See this. Thank you. Calculate the ripple factor for a pi type filter. This pi type filter is actually CLC filter. See here. Full wave rectifier. Thank you. Thanks everyone. This is the load resistance. Capacitor, inductor, capacitor. Now tell me, क्या दिखाई दे रहा है? Sir, this is CLC, 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 pi filter. Oh, so for pi filter, the formula for ripple factor will be √2 upon 8 omega square L C1 C2 RL. √2 upon 8 omega square L C1 C2 RL. Now students, in this particular question, they have given you the value of L as 10 Henry. L is given as 10 Henry. Two equal capacitors, we can say that C1 and C2 both are equal. They have given it as 15 farad. And fed from a full wave rectifier. Okay sir, the load resistance is 4 kilo ohms. 4 kilo ohms. Assume supply frequency of 50 hertz. Now students, can you put up all these values and do the calculations? Can you all do the calculations and find out? I want the answer in the comment box very quickly. So √2 divided by 8 omega square omega square L C1 C2 RL. What is L? L is 10 Henry. C1 and C2 both are same. So C1 C2 will be 16 micro square. 16 into 10 raised to minus 6 square multiplied by load resistance 4 kilo. Student, one beautiful part is in L section filter, the previous one, the ripple factor is independent of the load resistance. Here it is dependent on load. That is the bad part here. RL कितना है 4 kilo. What is the answer you are getting? We know. Omega square. Extremely sorry, it should be omega cube. It should be omega cube. Just make a correction. 8 omega cube. Huh? And hence the answer for the ripple factor is very, very low. 5.57 into 10 raised to minus 4. Yes. Comfortable everyone? So students, just in 5 minutes from now, I will be coming live on BYJU'S Exam Prep app, and there I will be teaching basic signal operations for 45 minutes. So 12 to 12:45 I will be coming live on BYJU'S Exam Prep app. If you have downloaded app in your mobile, then you can join that session also immediately after this session. For 40-45 minutes I will be taking a few examples, and there I will be explaining what are the basic operations that can be performed on signals. See this. For a 50 Hz AC input, the ripple frequency in the out, very simple question. Input AC, see, output of full wave rectifier. This is the input and this is the output. So we can say that output frequency output frequency is double to that of the input frequency. So if input frequency is 50 hertz, output of full wave rectifier will be having frequency 100 hertz. Comfortable? Let's move to the next. The RMS value of a half wave rectifier, very simple. See here, for half wave rectifier, RMS value is Im by 2. Can you tell me what is the RMS value of a full wave rectifier? For a full wave rectifier, what is the RMS value? Im by root 2. For a full wave rectifier, it is Im by root 2. Chaliye. Very simple question. One-liners will be there in your exam. Oscillator requires what kind of feedback? Everyone should answer. Everyone should answer this question. Everyone should answer this question. Comfortable. So when there is positive feedback, this will result in oscillations. When there is negative feedback, this may lead to amplification. That's all from my side, students. So I'll just announce something here. For NILEAG 2023 crash course for ECE and computer science will be starting from 18th of March. Don't miss out this opportunity. Monday, Wednesday and Friday technical sessions will be there. Every Saturday exclusive aptitude session, maybe by your favorite Rakesh Talreja sir. So students, you can subscribe this channel to get the advantage of this particular batch. Students, BYJU'S Exam Preps, this particular channel has started a new initiative, that is Coffee with Concepts. So students, let us make the concepts more hotter in the upcoming summer, and do join us twice a week for ECE electrical instrumentation on Wednesday and Sunday, for computer science Tuesday and Saturday. So we will be coming up with some beautiful concepts every time in these sessions. So do subscribe this particular channel and share this information in all your contacts. Looking forward to see you in these particular sessions. Think I am not getting. EG not mentioned means. Students, as you already know that UPSC ECE 2023 prelims results are already out. If you have appeared for this and you have got selected, you can share your results with us and you can avail amazing benefits, beautiful benefits from BYJU'S Exam Prep. Think I am not aware of this. Maybe you can ask this once Rakesh sir or Ashu sir will be there in any of the sessions. So he will be coming up with your, he will be definitely solving your doubt. Students, requesting all of you to hit the like button, subscribe this channel, share the link in all your contacts. That's all from my side. Jai Hind, Jai Bharat.